We have here a differential equation. So we have dy by dx in terms of y and x. So solving the differential equation means we need to result in an expression that has y in terms of x. So we need somehow to integrate, but we can't integrate when we have y and x together. We need to bring the y's alongside the y's and x alongside dx. So what we call this is separation of variables. We need to separate the variables. So we need to separate x and y. So one thing we could do is simply multiply both sides by dx. So if you think of that as having that effect, you'll then have dy equals 3 over y cosine squared x dx. So we've almost separated the variables. We've got the x with the dx, but we need to bring the y to the other side, and we can achieve that by multiplying both sides by y, because if you multiply by y, that cancels out. So I'll do that, there. Sorry, let's rewrite it as y dy equals 3 over cosine squared x dx. Now we've got the y alongside the dy, we've got the x alongside dx, so we're ready to integrate. So we just need to add integration signs and integrate away. So the integral of y dy, that's straightforward. It's just half y squared plus a constant. But I'm going to keep the constant for later. I'll add that to the right-hand side later. So that's the easy part. How do we integrate cosine squared in the denominator? It isn't easy. There isn't an integral for cosine squared when it's in the denominator, but it might be more familiar if you were to write it as 3 secant squared x dx, because we know that the integral of secant squared is tan, and obviously secant squared is 1 over, let me write that out for you in case you forgot. 1 over cosine x is secant x. So that's where this comes from. And the integral of secant squared is tan. So we can write that out as 3 tan x plus constant. Now we can stop there, but that wouldn't be solving our expression. To find the solution, we need y equals. So that means getting rid of this constant and getting rid of that power. So if you multiply both sides by 2, you'll have y equals square root of 6 tan x plus 2c under square root. Now, because we don't know what the constant is, we don't know what 2 times the constant is. So we might as well just replace 2c with another constant, d. So this would be our general solution. All right, we call it a general solution because we still don't know the value of d. So this is our general solution. Now, it's possible to find the particular solution if we're given a point x and y. Now, in the question, they're giving us that when x is pi over 4, y is 2. So that's useful information. We can plug that in. We can say when x is pi over 4, y is 2. Is that right? Yeah. So we just substitute these two numbers into x and y and then rearrange to find d. So we can do that. We can say 2 squared equals 6 tan pi over 4 plus d. Now, you might recognize pi over 4. Tan pi over 4 is just 1. Pi over 4 is equivalent to 45 degrees. So this is just 1. You can verify that with your calculator. So you have 4 minus 6 equals d. So d equals minus 2. So now we know the value of the constant, we can rewrite our general solution, and this time we're going to call it the particular solution. I mean, you don't have to call it the particular solution. You can just say that's the solution. But later on, you'll find it helpful to make this distinction. There you go. The solution where you don't have unknown variables or parameters is called the particular solution. So we've replaced d with minus 2, and we can now call this the particular solution. So we have y in terms of x, and there are no further unknowns. So that's the answer to that question.